Welcome to this episode. In this episode, we will introduce a new technology for tuberculosis detection that does not require sputum sample collection. It can directly detect and differentiate latent and active TB from serum. A team of faculty from Wayne State University has discovered new technology that will quickly and easily detect active Mycobacterium tuberculosis or TB infection antibodies. Their work, discoverer of novel transketolase epitopes and the development of IgG-Based tuberculosis Serodiagnostics, was published in a recent edition of Microbiology Spectrum, a journal published by the American Society for Microbiology. The team is led by Lobelia Samavati, MD, professor in the Center for Molecular Medicine and Genetics in the School of Medicine. Samavati was joined by Jaya Talreja, PhD, and Changya Peng, research scientists in Wayne State's Department of Internal Medicine. Active mycobacterial tuberculosis infection remains a global health threat, with 10 million new cases and 1.7 million deaths annually. 1/3 of the world's population is infected with TB, but not all are considered to have latent TB infection, or LTBI. Pulmonary TB is contagious and can be lethal, and LTBI can evolve into active TB. Efforts during the past decade to consistently diagnose and treat pulmonary cases have slowed the TB incidence rate, but they have not yielded substantial progress. The existing TB diagnostics pipeline still does not have a simple, rapid, inexpensive point-of-care POC test. The World Health Organization, or WHO, has defined high-priority target product profiles for tuberculosis diagnostics. These priorities include a sputum-based POC smear replacement test, a non-sputum biomarker-based POC TB test, a POC triage test, and a rapid drug susceptibility test, or DST. The discoveries of specific biomarkers in the form of antibodies distinguishing the immunity in active TB and LTBI could be keys to understanding the humoral responses against mycobacterial pathogens. Currently commercially available antibody-based TB tests show poor sensitivity and specificity, and none can distinguish active TB from LTBI. Due to the lack of precision, the WHO does not endorse the routine application of the current commercial serological tests for TB diagnosis. The serological diagnosis of tuberculosis has been challenging, partly due to the large MTB proteome, the even larger antigenic epitopes, and the heterogeneity across humans in their immunoglobulin G (IgG) responses to tuberculosis. Most tuberculosis serological tests use purified MTB proteins and a single or small number of antigens that are predominantly derived from the membrane proteins of MTB. The challenges for development of effective serological tests include the need to differentiate active pulmonary TB from other pulmonary diseases, including pneumonia, or other granulomatous diseases, such as pulmonary sarcoidosis. The gold standard tests to determine whether an infection is active TB are the sputum smear and culture tests. However, these methods require collecting sputum, which is time-consuming, expensive, requires trained personnel, and lacks sensitivity. The current conventional tests differentiating LTBI from uninfected controls, such as tuberculin skin test (TST) and or interferon gamma release assay (IGRA), do not differentiate between active TB infection and latent TB. Despite advances in rapid molecular techniques for tuberculosis diagnostics, there is an unmet need for a simple, inexpensive, point-of-care, rapid, non-sputum-based test. Samavati's research group has worked for more than 15 years to develop technology for detection of antibodies in various respiratory diseases. Her lab has developed a novel non-sputum-based technology and has discovered several novel immune epitopes that can differentially bind to specific immunoglobulin in TB-infected subjects. The levels of epitope-specific IgG in serum can differentiate active TB from LTBI subjects, healthy controls, and other respiratory diseases. This technology can be used as a simple serum assay non-sputum based serological POC TB test, which is highly specific and sensitive to differentiate active TB from LTBI. Previously, they developed a T7-phage antigen display platform and after immunoscreening of large sets of serum samples, identified 10 clones that differentially bind to serum antibody IgG of active TB patients, differentiating TB from other respiratory diseases. One of these high-performance clones had homology to the transketolase TKT enzyme of TB bacteria that is an essential enzyme required for intracellular growth of the bacteria in a host. They hypothesized that abundance of IgG in sera against the identified novel neoantigen that they named as TKT-mu can differentiate between active TB, LTBI, and other non-TB granulomatous lung diseases such as sarcoidosis. They developed a novel direct peptide ELISA test to quantify the levels of IgG in serum samples against TKT-mu. They designed 2 additional overlapping MTB-TKT peptide homologs with potential antigenicity corresponding to MTB-specific transketolase MTB-TKT1 and MTB-TKT3, and hence standardized 3 peptide ELISA, TKT-mu, MTB-TKT1, and MTB-TKT3 for the TB serodiagnosis. After development and standardization of a direct peptide ELISA for 3 peptides, the research team tested 292 subjects, and their TKT peptide ELISA results show that TB patients have significantly higher levels of TKT-specific antibodies compared to patients who are healthy controls and with LTBI. The increased level of TKT-specific antibodies is presumably associated with the growing MTB bacteria in active TB patients. TKT plays a key role in the switch from the dormancy to proliferative stage, and TKT-specific IgG may uncover the differences between active TB and LTBI. Thus, IgG-based serodiagnosis of TB with TKT peptide ELISA is promising. In conclusion, currently commercially available serological TB tests show poor sensitivity and specificity. The ELISA results obtained with the Wayne State team's discovered TKT peptides yielded high specificity and sensitivity. The results show that IgG antibodies against transketolase can discriminate active tuberculosis. The research team has applied a patent application on its technology and is actively seeking companies interested in investing.